Dear students, welcome. After a long time we are meeting. This is our fourth class on pair of straight lines, coordinate geometry, 2 dimensions. This chapter is included in BSc third semester mathematics honors. We are discussing some problems on pair of straight lines. Today we shall discuss about some problems on pairs of straight lines. First of all, we are going to solve a problem if the general equation of second degree ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0 represents a pair of straight lines. Then if we draw the perpendiculars from the origin on these two straight lines, then we have to show that the product of the perpendiculars from the origin on the straight lines is c divided by root over a minus b whole square plus 4h square. Let us start. This problem is if the general equation of second degree, if the equation ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0, the general equation of second degree represents a pair of straight lines. Then the product of the perpendiculars from the origin on these straight lines is c divided by root over a minus b whole square plus 4h square. We know that the homogeneous equation of second degree ax square plus twice hxy plus by square equal to 0 always represents a pair of straight lines passing through the origin. Under some certain conditions, this general equation of second degree also may represent a pair of straight lines. Let us suppose that the straight lines represented by this is suppose L1x plus M1y plus N1 equal to 0 and M2x plus M2y plus N2 equal to 0. Let us suppose that let the straight lines represented by ax square plus twice hxy ax square plus twice hxy plus by square plus twice gx plus twice fy plus c, this is equal to 0. B L1x plus M1y plus M1 equal to 0. Suppose this is number 2 and L2x plus M2y plus M2 equal to 0. Suppose this is number 3. One represents a pair of straight lines. Suppose the straight lines represented by 1, B, 2 and 3. Suppose this. The combined equation of 2 and 3 is the combined equation of 2 and 3 is L1x plus M1y plus M1 into L2x plus M2y plus M2 this is equal to 0. This implies L1 L2 x square plus L1 M2 plus L2 M1 xy plus M1 M2 y square plus L1 M2 plus L2 M1 x M1 M2 plus M2 M1 y plus M1 M2, this is equal to 0. Suppose this is number 4. This is number 4. You see, 3 terms multiplied by 3 terms, we will get 9 terms. We have written 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 terms. Notice, 1 represents 2 straight lines. The straight lines are 2 and 3. Combined equation of 2 and 3 is this. What does it mean? These 2 equations, 1 and 4, represent the same pair of straight lines. Now, 1 and 4 represent the same pair of straight lines. Same pair of straight lines. 1 and 4 represents the same pair of straight lines. Comparing 1 and 4 we get 1 and 4 we get L1 L2, this is equal to A, M1 M2 equal to B, M1 M2 equal to C, L1 M2 plus L2 M1, this is equal to twice H, L1 M2 plus L2 M1 equal to twice Z, M1 M2 plus M2 M1, this is equal to twice F. Equal to twice F. Equal to twice F. We have got this. Now, what is our question? Question is, product of the perpendiculars drawn from the straight line, drawn from the origin on the straight lines 2 and 3 is C divided by root over A minus B whole square plus 4A square. Now, suppose that let P1 and P2 be respectively the perpendiculars drawn from 0, 0, drawn from the origin, drawn from 0, 0 on the straight lines 2 and 3, on the straight lines 2 and 3. Therefore, P1 equal to, the straight line was L1x plus M1y, L1 from the point 0, 0, L1 into 0, M1 into 0, M1 divided by root over M1 square plus M1 square. This is equal, this means P1 equal to M1 by root over L1 square plus M1 square. L1 square plus M1 square. Similarly, P2 equal to L2 into 0, M2 into 0 plus M2 divided by root over L2 square plus M2 square. This means P2 equal to M2 divided by root over L2 square plus M2 square. Now, P1, P2. This is equal to n1 by root of r l1 square plus m1 square into m2 by root of r l2 square plus m2 square. We have got this. This is equal to n1 m2 divided by root of r l1 square plus m1 square into l2 square plus m2 square. This is equal to, this is nothing but c. You may write l1 m2, this is equal to c. n1 m2 equal to c. n1 m2, this is equal to c. Root of r l1 square l2 square plus l1 m1 square m2 square. You write here this m1 square m2 square. m1 square m2 square plus l1 square m2 square plus l2 square m1 square. Root of r l1 l2 whole square m1 m2 whole square plus, you may write here m1 m2 plus l2 m1 whole square minus twice l1 l2 m1 m2. You may write like this. It is of the form a square plus b square. This is equal to a plus b whole square minus twice ab. This is equal to c by root of r. L1 L2 is nothing but a. This is b. M1 M2 equal to b. M1 M2, this is equal to b plus L1 this is equal to twice h whole square minus twice ab. This is equal to c divided by root of r. A square plus b square minus twice ab. You will get a minus b whole square plus it is nothing but 4a square. Therefore, the product of the perpendiculars drawn from the origin on this straight lines is equal to this. Let us take another example of this type. If the equation, today's example number 2, if the equation, the general equation of second degree, ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0. If the equation represents two straight lines, a pair of straight lines means two straight lines. If the equation represents two straight lines equidistant from the origin, then show that f to the power 4 minus g to the power 4 c into bf square minus ac square. This time we are given that ax square plus twice hx square, this is the general equation of second degree, represents a pair of straight lines, represents two straight lines. The straight lines are such that the distance from the origin on these straight lines, perpendicular distance from the origin on these straight lines are always equal. Then we have to prove this one. Just as the previous problem, let the straight lines represented by ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0. b L1x plus M1y, N1 equal to 0, suppose this is number 2, and L2x plus m2y plus m2. This is equal to 0. Suppose this is number 3. Suppose this is number 3. The combined equation of 2 and 3 is combined equation of 2 and 3 is L1x plus M1y plus M1 into L2x plus M2y plus M2. This is equal to 0. This means L1 L2 x square plus L1 M2 plus L2 M1 xy M1 M2 y square plus L1 M2 plus L2 M1 x plus L1 plus M1 M2 this is equal to 0. Just multiply this and this, you will get this. Suppose this equation, the number of this equation is 4. 1 and 4 represent the same pair of straight lines. 1 and 4 represent the same pair of straight lines. Comparing 1 and 4, we get L1 L2 equal to A, M1 M2 equal to B, N1 M2, M2 plus L2 M1 equal to twice H, L1 M2 plus L2 M1 twice Z, and M1 M2 plus M2 M1. This is equal to twice F. Equal to twice F. According to the question, now you may write according to the question. According to the question, the perpendicular distance from the origin 0, 0 on these straight lines 2 and 3 are equal. According to the question, equidistant from the origin means M1 into 0, M1 into 0 plus M1 divided by root over L1 square plus M1 square. This is equal to L2 into 0 plus M2 into 0 plus M2 divided by root over L2 square plus M2 square. L2 square plus M2 square. According to the question, this means M1 by root over L1 square plus M1 square. This is equal to M2 square. Or you may write M1 into root over L2 square plus M2 square. This is equal to M2 into root over L1 square plus M1 square. M1 squaring plus M1 square. Now square both sides. Squaring we get M1 square into L2 square plus M2 square. This is equal to M2 square into L1 square plus M1 square. You will get this. This means L2 square M1 square minus M2 square L1 square. This is equal to M1 square M2 square minus M2 square N1 square. We have taken this term to the left side and this term m2 square n1 square to the right side. We have taken this one. Now see, what is of the form a square minus b square? Means a plus b into a minus b. A plus b into a minus b. This is equal to. Similarly, here also plus m2 m1. m1 m2 minus m2 m1. Similarly, you will get this. Now see, what is this? This is equal to twice z. Twice z. It is nothing but twice z. L2 N1 plus M2 L1. This is equal to twice z. What is this? It is of the form a minus b. We know that a plus b whole square minus a minus b whole square, this is equal to 4ab. It is a minus b. A minus b equal to, you will get a plus b whole square minus 4ab. This is equal to, what is this? M1, M2. This is equal to twice f into root of r. What is this? It will be m1, m2 plus m2, m1 whole square minus 4 m1, m2, m1, m2. Thus, we have to simplify this. Thus, simplify. First. 2 from both sides will be cancelled. This means z into root of r. L2 L1 plus N2 L1. What is this? This is equal to twice z. Twice z whole square minus 4ac. 4ac. This is equal to f into root of r. This is nothing but twice f whole square minus 4 bc. This means z square into 4 times of z square minus ac. This is equal to f square into 4 times of f square minus bc. Squaring both sides. Squaring both sides. Squaring both sides. Now 4 will be cancelled. Z to the power 4 minus AC z square. This is equal to f to the power 4 minus BC f square. This means f to the power 4 minus z to the power 4 equal to BC f square minus AC z square. This is equal to C into BF square minus AZ square. F to the power 4 minus z to the power 4 equal to C into BF square minus AZ square. Proved. Proved. Now we shall try to solve another problem, which is, suppose we are given a curve. Suppose we are given a curve x square plus twice xy plus thrice y square plus twice x plus y minus 11 equal to 0. Suppose this is a curve. And also we are given a straight line. There will be 2 points of intersection between the curve and the straight lines. And the straight line. The curve and the straight line will cut in 2 points. If we join the origin to these points of intersection, then what is the combined equation of the straight line? We have to find the straight line joining the origin to the points of intersection between the curve and the straight line. Then there must be some angle between these two straight lines. What is the angle between the straight lines joining the origin to the points of intersection of the curve and the straight line? We are going to solve this problem. Prove that the angle joining the origin to the points of intersection between the curve suppose the curve is x square plus twice xy plus thrice y square, suppose, plus, let us take it 4x plus 8y minus 11 equal to 0. Suppose the curve is this, between the curve this and the straight line, thrice x minus y plus 2 equal to 0. This is a straight line. Thrice x minus y plus 2 equal to 0, straight line. The given curve is this and the given straight line is this. There will be 2 points of intersection. We join these 2 points of intersection to the origin. Join the points of intersection to the origin. Then the angle between these 2 straight lines is, and the straight line Iman, prove that the angle joining the origin to the points of intersection between the curve Iman and the straight line Iman is tan inverse 2 root 2 divided by 3. 2 root 2 divided by 3. We solve this problem in this way. The given curve is x square plus twice xy plus thrice y square plus 4x plus 8y minus 11. This is equal to 0. The given straight line is thrice x minus y plus 2 equal to 0. Given straight line is this. Now notice one question. This is a curve, this is a straight line. This is a curve, this is a straight line. It will cut in 2 points. Suppose this is origin. We will join the origin to the points of intersection. We have to show that this angle is tan inverse 2 root 2 divided by 3. We have to show that this angle is tan inverse 2 root 2 divided by 3. Now you see that homogeneous equation of second degree of the form ax square plus twice xy plus by square equal to 0 represents a pair of straight lines passing through the origin. Since these 2 straight lines pass through the origin, therefore the combined equation of the straight line will be of the homogeneous form, that is ax square plus twice xy plus by square, this is equal to 0, will be of the homogeneous form. Means there will be no term involving x, y and also a constant term. This equation must be a homogeneous equation of second degree. Now we write like this. We know that we know that a homogeneous equation of second degree always represents a pair of straight lines. Always represents a pair of straight lines passing through the origin. Homogeneous equation of second degree always represents a pair of straight lines passing through the origin. Now, we are going to construct a homogeneous equation of second degree using 1 and 2. That equation will construct a homogeneous equation of second degree with the help of 1 and 2. That equation will definitely represent a pair of straight lines passing through the origin to the points of intersection, between 1 and 2. Now, I am writing here. Now we construct. If we construct a homogeneous equation of second degree, with the help of 1 and 2, then that homogeneous equation of second degree will clearly represent the straight lines passing through the origin to the points of intersection between 1 and 2, to the points of intersection between 1 and 2. Between 1 and 2. Now 2 implies, this means y minus thrice x equal to 2 means y minus thrice x divided by 2 equal to 1. Now 1 implies x square plus twice xy plus 3y square plus 4x plus 8y minus 11 equal to 0. Suppose this is number 3. Minus 11, this is equal to 0. The curve is this. Now see, this is a homogeneous equation. This is a term of second degree. This is also second degree. This is also second degree. We don't have any problem from this. 4x into 1. For this 1, you write y minus thrice x divided by 2 plus 8y. For this 1, you write y minus thrice x divided by 2 minus 11 into y minus thrice x divided by 2 whole square using 3. Now see. x into 1. For 1, we have written y minus thrice x divided by 2. There is no problem. For 8y, we have written here 8y into y minus thrice x divided by 2. Since this is equal to 1, Therefore, we have done no mistake. For this also, we have written 1 square. 1 square means 1. 11 into 1 is equal to 1. Using 3, we have written this. You see, this is a homogeneous equation of second degree. This is a homogeneous equation of second degree. Now, 2 will be cancelled here, and it will be 4. Now see how many terms are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms are there. Out of these 10 terms, the terms involving x, here it is 1. It is 1. This is twice x into minus thrice x. What is this? Minus 6 x square. Minus 6 x square. Minus 6. Right there, minus 6. There will be no term involving x square here. Minus 11 by 4 into, you will get 3 square. 3 square means 9 into x square. The terms involving x square will be this. Terms involving xy, you write terms involving xy. Here it will be 2, and multiply this and this, you will get twice xy, you will get another 2. Minus 3 x y into 4y, minus 12 xy, you will get minus 12. Minus 11 by 4 into minus 6 xy, you will get minus 6 xy. Now terms involving y square, you will get, here it is 3y square. There is no term containing y square. It is 4 plus 4y square minus 11 by 4 whole square equal to 0. Now see, here we have written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All terms have been written here. This means, now multiply it by 4. Multiply both sides by 4. You will get, it is minus 5. Minus 5 into 4 means minus 20. Minus 99 into x square. Plus 4 minus 12 means minus 8. Minus 32. Minus 32. Plus 66 xy. Plus 28 minus 11. Y square, this is equal to 0. Y square equal to 0. This means minus 119 x square plus 34 xy plus 34 xy plus 17 y square equal to 0 plus 17 y square, this is equal to 0. Now divide it by 17. If you divide it by 17, minus 7 x square plus twice xy plus y square, this is equal to 0. Divide by 17. You will get this. This is a homogeneous equation of second degree. It will represent two straight lines passing through the origin. Suppose this is number 4. This equation is number 4. This is a homogeneous equation of second degree. What is the angle between the two straight lines represented by 4? Tan inverse 2 times of root over a square minus ab divided by a plus b. Let phi be the angle between the two straight lines represented by four. Represented by 4. Now we write here 7x square minus twice xy minus y square equal to 0. Suppose this is number 4. Represented by 4. Therefore, tan phi equal to 2 times of root of r. Use this formula, h square minus ab divided by a plus b. Or you may write tan phi, this is equal to 2 times of root of r. What is h here? H is equal to minus 1. Minus ab, 7 into minus 1 divided by a plus b. Divided by a plus b. We have used this formula, tan phi equal to 2 times of. This always represents a pair of straight lines passing through the origin. The angle between these straight lines is tan inverse 2 times of root over a square minus ab divided by a plus b. This means tan phi equal to 2 times of root over 1 plus 7 divided by 6. 1 plus 7 divided by 6. Root over 8 by 3. This is nothing but 2 root 2 by 3. This means phi equal to tan inverse 2 root 2 divided by 3. 2 root 2 by 3. Phi equal to tan inverse 2 root 2 divided by 3. You will have to remember this formula. Tan phi equal to 2 times of root over a square minus ab divided by a plus b. Remember this formula. Suppose you don't remember this, then you have forgotten this formula. Suppose, then in an alternative way, we shall find the angle between the straight lines represented by 4. Now 4 implies 7x square minus twice xy minus y square, this is equal to 0. Multiply it by 7. 49 7 square minus 14xy minus 7y square, this is equal to 0. This means 7x whole square 2 times of 7x into y plus y square, this is equal to y square plus 7y square. You may write like this also. Now see the left hand side. It will be 7x minus y whole square. This is equal to 8y square. 8y square. This means 7x minus y equal to plus minus 2 root 2y. 2 root 2y. Or 7x equal to y plus minus 2 root 2y. This is equal to 1 plus minus 2 root 2 into y. 7x equal to, this means y equal to 7 divided by 1 plus minus 2 root 2x. Obviously this is a straight line. There are two straight lines. One is y equal to 7 by 1 plus 2 root 2 x. Another is y equal to 7 divided by 1 minus 2 root 2 into x. These are two straight lines. Thus the straight lines are y equal to 7 by 1 plus 2 root 2x. Suppose this is number 5, and y equal to 7 by 1 minus 2 root 2x. Suppose this is number 6. Now slope of straight line 1, straight line 5 is m1 equal to 7 divided by 1 plus 2 root 2. Slope of straight line 6 is m2 equal to 7 by 1 minus 2 root 2. 7, 1 minus 2. Let phi be the angle. Let phi be the angle between the straight lines. Angle between the straight lines. Five and 6. 5 and 6. Therefore, tan phi equal to m2 minus m1 divided by 1 plus m1 into m2. m2 minus m1 divided by 1 minus 1 plus m1 into m2. This means tan phi equal to, what is m2? m2 is equal to 7 by 1 minus 2 root 2 minus 7 by 1 plus 2 root 2 divided by 1 plus 7 by 1 plus 2 root 2 into 7 by 1 minus 2 root 2. This means tan phi equal to seven. You may take 7 common. 1 plus 2 root 2 minus 1 plus 2 root 2 divided by 1 plus 2 root 2 into plus 7 square. 7 square means 49. This is equal to 7, 4 root 2. This plus 1 minus 1 will be cancelled. 1 minus 8. 2, this is equal to 8. Plus 49. Since 2 root 2 whole square equal to 8. 2 root 2 whole square equal to 8. This is equal to 7 into 2 root 2 divided by 42. Here this 6, 4 root 2. 7 into 4 root 2. 6. This is 2, this is 3. This means tan phi. This means tan phi equal to 2 root 2 divided by 3. This means phi equal to tan inverse 2 root 2 divided by 3. In this way also, we can find the angle between the two straight lines. In this way also, we can find that. Oh. Let us take another example. Show that the equation 8x square minus 14xy plus 6y square twice x minus y minus 1 equal to 0. Suppose this. Okay. So that the equation represents a pair of straight lines. Pair of straight lines. Find Find their point of intersection. Find also their point of intersection and the angle between them. We are given an equation. We have to show that this equation represents a pair of straight lines. If it represents a pair of straight lines, if the two straight lines will cut at a point, which is called the point of intersection. We have to find that point of intersection. Also, it will cut at the point of intersection. This will be the point of intersection, and this angle will be the angle between the two straight lines. If the two straight lines passing through the origin, suppose this is origin O, passing not origin. This is not origin. Now, in the first class, we told you that the general equation of second degree, ax square plus twice xy plus by square plus twice gx plus twice fy plus c equal to 0 represents a pair of straight lines if abc plus twice fgh minus af square minus bg square minus ch square, this is equal to 0. This is the condition that the general equation of second degree may represent a pair of straight lines. Now we know that the equation, the general equation of second degree, the equation ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0 represents a pair of straight lines. If ABC plus twice FGH minus AF square minus BG square minus CH square equal to 0. If this. Here, you see here, A equal to 8, B equal to 6, C equal to minus 1, H equal to minus 7, Z equal to also 1, and F equal to minus half. Therefore, ABC plus twice FGH minus AF square minus BG square minus CH square, this is equal to A means 8, 6, minus 1. ABC plus twice FGH, twice FGH. FGH minus AF square. A means 8. F square. F is equal to minus half. AF square minus BG square 6 into 1 square minus CH square minus 7 whole square minus 48. It will be plus 7. It will be minus 2. Next minus 6. Next plus 49. This is equal to minus 48 minus 2 minus 6 minus 56 plus 56 equal to 0. Since ABC plus twice FGH minus AF square minus BG square minus CH square equal to 0, therefore the given equation represents a pair of straight lines. Here, therefore the given equation represents a pair of straight lines. Since for the given equation, suppose 8x square minus 14xy plus 6x square plus twice x minus y minus 1 equal to 0, ABC plus twice FGH minus AF square minus BC square minus CH square equal to 0. Therefore, 1 represents a pair of straight lines. A pair of straight lines. 1 represents a pair of straight lines. Now, what is the point of intersection between the two straight lines? The point of intersection is ASF minus BG by AB minus A square, GH minus AF by AB minus A square. The point of intersection between these straight lines, the point of intersection will be ASF minus BG by AB minus A square, GH minus AF divided by AB minus A square. Minus AF by AB minus A square. Now, HF minus BG, this is equal to, what is H? Minus 7, F minus half, minus BG 6 into 1. This is equal to 7 by 2 minus 6 equal to minus 5 by 2. AB minus H square equal to 6, AB 8 into 6. 8 into 6 minus 7 square minus 7 whole square. 48 minus 49. This is equal to minus 1. GH minus AF. GH minus AF. 1 into H minus 7 minus AF. 8 into minus half. This is equal to minus 7 minus 7 plus 4 equal to minus 3. Am I right? Therefore, the required points of intersection are, therefore the required point of intersection, is equal to minus 5 by 2 by minus 1 minus 3 by minus 1, that is equal to 5 by 2 3. This is the point of intersection. 5 by 2 3. 5 by 2 3 is the point of intersection. What is the angle between the two straight lines? The angle phi between the two straight lines is given by phi equal to tan inverse 2 times of root over a square minus AB divided by A plus B. This is the angle between the two straight lines. Phi equal to 2 times of root over minus tan inverse minus AB divided by 8 plus 6. Tan inverse 49 minus this is equal to tan inverse 1 by 7. This is the answer. Tan inverse 1 by 7. We have got another two answers. The point of intersection is 5 by 2, 3, and the angle between the two straight lines is tan inverse 1 by 7. Now, we can solve this problem in another method also. Just let us try to solve this problem in an alternative way. Now, the alternative method. Alternatively. Alternative method. The given equation is 8x square minus 14xy plus 6y square plus twice x minus y minus 1 equal to 0. Multiplying 1 by 8. Suppose this is number 1 by 8. You will get 64x square minus plus plus 16x minus 8y minus 8 equal to 0. Multiply it by 8. Now you see 8x whole square minus 2 times of 8x into 7y. Multiply it by no. One second. It is, if you multiply it by 8, you will get 2 into 7 into 8. Yes, you will have to write it here 7y. You will have to write 7y. 2 into 8x into 7y plus 7y whole square. Plus 7y whole square. Multiply it by 8x whole square. If you multiply it by 8, then you will get 2 into 7 into 8. 7 whole square. This is equal to, we have written the term involving x square as it is, and term involving xy also, it is also as it is. Now, you will have to write here in the right hand side 7y square, no problem, plus 2 into 8x into 1. You may write, for 16x you will have to write 2 into 8x into 1 plus 2 into 7y into again 1. 1 minute. Here it is minus. Here it is minus. Therefore, you will have to write here. Well, you may write here plus into minus this. Here also you may write minus 7y whole square plus 2 into minus 7y into 1 plus 1 square plus 1 square. This is equal to, it has been written minus 7y whole square. You will have to write here minus 7y whole square minus 48y square. Minus 48y square. 16x, we have written 16x. Minus 14y. And 8y will be, will have to be written here plus 8y. Plus 8y. Plus 8 plus 1 square. Am I right? Just check it. For this, 2 into 8x 7y. With a minus sign, you may write minus 7y whole square. We have written additionally minus 7y whole square. Therefore, in the right hand side also we have to write minus 7y whole square. There will be no problem between this term. 48y square, if you write here, we have written here in the right hand side. 16x, there is no problem for the term 16x. Minus 8y, we have written minus 8y. Minus 14y, additionally, we wrote in the left hand side, therefore in the right hand side also we have written this. I think the calculation is correct. Now see the left hand side. It is of the form a square plus b square plus c square plus twice ab plus twice bc plus twice c into a. This is equal to a plus b plus c whole square. 8x minus 7y plus 1 whole square. This is equal to 49. This is 49y square minus 48y square means y square minus, it is 6y plus 9. 6y plus 9. This means minus 7y. Equal to, it is nothing but y minus 3 whole square. This means 8x minus 7y plus 1 equal to plus minus y minus 3. Plus minus y minus 3. That is 8x minus 7y plus 1 minus y plus 3 equal to 0 and 8x minus 7y plus 1 plus y minus 3 equal to 0. That is 8x minus 8y plus 4 equal to 0 and 8x minus 6y minus 2 equal to 0. Minus 2, this is equal to 0. That is twice x minus twice y plus 1. Twice y plus 1 equal to 0 and 4x minus thrice y minus 1 equal to 0. Suppose this is number 2 and number 3. Therefore, the given equation represents two straight lines. The two straight lines are this and this. Therefore, the given equation 8x square minus 14xy plus 6x square plus twice x minus 1 minus y equal to 0 represents two straight lines. Two straight lines which are 2 and 3. Represents two straight lines which are 2 and 3. Now see. Now these two straight lines, we can easily find the point of intersection between the two straight lines 2 and 3. Solving 2 and 3 we get 2 and 3 we get x divided by y divided by 1 divided by x divided by minus 2 into minus 1 minus 3 into 1 y by 1 into 4 minus 2 into minus 1 divided by 2 into minus 3 minus 4 into minus 2. This means x divided by 2 plus 3 5 y by 4 plus 2 6 1 by minus 5 plus 6 minus 6 plus 8 minus 6 plus 8 minus 6 plus 8 equal to 2. This means x equal to 5 by 2 y equal to 6 by 2 equal to 3. Therefore the points of intersection between 2 and 3 is between 2 and 3 is point of intersection between 2 and 3 is 5 by 2 3. We have got the same result. The point of intersection between 2 and 3 is 5 by 2 and 3. Now what is the angle between the two straight lines 2 and 3? Slope of equation line 2, slope of straight line 2 is m1 equal to 1. 2 divided by 2 equal to 1. Slope of straight line 3 is m2 equal to 4 by 3. 4 by 3. Therefore the angle phi between the two straight lines 2 and 3, the straight lines 2 and 3 is given by tan phi equal to m2 minus m1 divided by 1 plus m1 into m3. This is equal to 4 by 3 minus 1 plus 4 by 3 into 1. This means tan phi equal to 4 by 3 minus 1 1 by 3 7 by 3. This means tan phi equal to 1 by 7. This means phi equal to tan inverse 1 by 7. We have got the same result. In this way also we can solve this problem. We can find the point of intersection between the two straight lines 5 by 2 3, and the angle between the two straight lines is tan inverse 1 by 7. Dear students, I want to stop here. Thanks for attending the class. Thank you very much. Thank you.